Oh, okay. Here's a way to think about this. We've got this function f of x equals -2 cosine of x, and we're supposed to figure out where that function is concave up and where it's concave down using the test for concavity. So over here we have the red graph is the graph of the original function. The green graph or the blue graph is the first derivative, and the green graph is the second derivative. And to apply the test for concavity, we want to know when does the second derivative equal 0. And we're only interested in the interval from -2 pi to 2 pi. So we want to solve this equation. Divide both sides by 2 and then solve for x by saying x equals the inverse cosine of 0, or the angle or angles that have a cosine of 0. And the angles between -2 pi and 2 pi that have a cosine of 0 are any angles with the terminal side along the y-axis, because there the cosine or the x-coordinate will be 0, and the x-coordinate on the unit circle is the cosine of that angle. So these are the angles where the second derivative is equal to 0, and you can see that by looking at the green graph. There's the -3 pi over 2. There's the -pi over 2, hard to see. There's the pi over 2, and there's the 3 pi over 2. Okay, so that's where the second derivative is equal to 0. And what you want to do is draw your little number line like this, and we're applying the test for concavity. When the second derivative is positive, the original function is concave upward. I like to think positive equates to a smiley face, and negative implies a frown. That's how I remember it. And so how do you determine the sign of the second derivative in each of these sections? Well, you could pick a number between -2 pi and -3 pi over 2 and plug it into your calculator. Or you could look at the graph, or you could think, what quadrant is this? Between -2 pi, well, -2 pi is this angle right here, and -3 pi over 2 is this angle. So angles that have a terminal side in that interval are in the first quadrant. And in the first quadrant, the cosine is positive. Or you can look at the second derivative graph here from -2 pi to 3 pi over 2. The second derivative right there is positive. It's above the x-axis. So again, when the second derivative is positive, the original function is concave up. And you can apply similar logic to all of these intervals. And just notice that the original function in red here from -2 pi to 3 pi over 2, that's a concave up curve. And since the concavity changes at -3 pi over 2, that's actually a point of inflection for the original curve. The tangent lines have gone from increasing as we move this way to all of a sudden the tangent lines are decreasing its slope, and then the concavity changes here again. Okay, there you go. Hope that helped. If you have any questions, post a comment.